Welcome. We're gonna try to make the exercise a bit harder, and we're gonna see what happens when we have a triple of numbers that we want to calculate the greatest common divisor and lowest common multiple of. So we have 45, 60 and 75, but the first step is always the same. We have to factorize with prime numbers these three numbers. So let's draw three vertical lines. We write on the left hand side the numbers we want to factorize. In this case 45, 60 and 75. Okay, let's start with 45. It's not an even number, we cannot divide by 2. Let's see the sum of the digits. It's 4 plus 5 is 9. 9 is a multiple of 3, therefore we can divide this number by 3. 45 divided by 3 is 15. 15 is an easy multiple of 3. We have much trouble in knowing that it can be divided by 3. Result is 5. 5 is a prime number, can only be divided by 1 in itself, so that's what we're going to do. 5 divided by 5 is 1. Alright, we have factorized 45. Let's write it explicitly here. We have to multiply all the numbers on the right hand side. So 3 times 3 times 5. And this means that it's 3 to the power of 2 times 5. Okay, great. Let's now factorize 60. 60 is an even number. This time we can divide it by 2. And let's do that. 60 divided by 2 is 30. 30 is also an even number. Let's divide it by 2 again. 30 divided by 2 is 15. We're already familiar with the factorization of this number, so we divide by 3 first. The result is 5. Prime number again, 1. Okay, so let's write 60 as a product of prime numbers. We have 2 times 2 times 3 times 5. All the numbers here on the right hand side. 2 times 2, we can write it in a shorter way with the power rules. 2 to the power of 2 times 3 times 5. Great. There's only one number left to factorize, and let's do that. We have 75, an odd number. We cannot divide by 2. See, the sum of the digits is 7 plus 5 is 12, which is a multiple of 3. Therefore, we can divide by 3. 75 divided by 3 is 25. And we know from the multiplication table that this number can be divided by 5, but we notice also that the last digit is 5. This also tells us that it can be divided by 5. And let's do that. 25 divided by 5 is 5. Prime numbers. Oh, we are done with it. So let's write 75 here, can be written as 3 times 5 times 5. We also appreciate to write it in the shortest way possible. So I'm going to write 3 times 5 to the power of 2. Okay, now we have just to select the ingredients for the greatest common divisor. We start by noticing that 2 is only present in the factorization of 60. Therefore, we have to exclude it. It's not a common factor. We can only take common factors, and we're going to take them with the lowest exponent. 2 must be present in all 3, but it's not, therefore we cannot take it. Let's see 3. We have 3 to the power of 2 here, 3 here, and 3 here. So it's a common factor. All 3 have it at the same time. Therefore, we can take it. But we have to take it with the lowest exponent and only one time. So 3 to the power of 2 is surely bigger than 3 to the power of 1. We already mentioned how the exponent is in divisible. And here also we have 3 to the power 1. So we can only take 3 or 3 to the power 1 only one time. So you choose from which one you want to pick it. I'm going to pick it from here. That's okay with you? Now let's examine 5. 5 is present in all the 3 numbers, so it's a common factor. Which one has the lowest exponent? Yeah, you can already see that here we have 5 to the power 1, 5 to the power 1, and here 5 to the power of 2. We have to take 5 to the power of 1 and only one time. You choose from which factorization you want to take it. I'm going to pick it from 45. Well, that's only a multiplication left to calculate the greatest common divisor. So let's do that. Greatest common divisor of these 2 numbers. Which means 3 times 5, which is of course 15. That's our greatest common divisor. Let's see what happens with the lowest common multiple instead. We are going to recycle the factorization we have executed here. So I'm just going to copy here on the right. This is 3 to the power of 2 times 5. 60 is 2 to the power of 2 times 3 times 5. And 75 is 3 times 5 to the power of 2. For the lowest common multiple, we have to take common and non-common factors with the highest exponent. So here we have 2, it appears only here, so we don't have much choice. It's a non-common factor, you have to take it, and the exponent doesn't matter, in this case it's 2 to the power of 2, but anyway we would have taken it because it's the only time 2 appears. Let's see for 3, where we have 3 to the power of 1, same thing here, but here we have 3 to the power of 2. And for the lowest common multiple, we are forced to take it one time with the highest exponent. Alright, now 5, same reasoning that we had with 3. It appears in all 3, okay, we can only take it one time and we have to take it with the highest exponent. And the choice is obviously 5 to the power of 2. Now we only one multiplication left for the lowest common multiple. So lowest common multiple of these 3 numbers is equal to the product of these 3 numbers I circled in red. Means 3 to the, no, let's start from the smallest one. 2 to the power of 2 times 3 to the power of 2 times 5 to the power of 2. 2 to the power of 2 is 4 times 3 to the power of 2 is 9 times 5 to the power of 2 is 25. And this calculation is going to give us as a result 900. You can use a calculator if it troubles with it. These ways to see that 4 times 25 is 100, 100 times 9 is 900. And that's the least common multiple that these 3 numbers have. Alright, the exercise is concluded.